So a algebraic expression consists of terms, each of these terms will consist of two parts, a numerical part and a variable part. So we have a variable part and we have a numerical part. This numerical part is called the numerical coefficient, and we usually just say coefficient. So let me do some examples. Let's say on page 30, let me do problem number 4. Negative 3lm negative 3lm. In exercises 1 through 14, write down the numerical coefficient for each term. And so, let's determine the coefficient. So in this particular case, the coefficient is negative 3. Let me do problem number 11, x to the fifth. So in this case, we don't explicitly have a number being multiplying the variable part, x to the fifth. And so when this situation occurs, we say that the coefficient is 1 because we can think that this term here can be written as 1 times x to the fifth. And so we can consider that the coefficient in this particular case is a positive 1. Let me look at problem number 14. Negative 2 squared xy squared z squared. No, that's z cubed. And so the numerical coefficient in this particular case, the number multiplying the variable part, is just a negative 2 squared. Let me do problem number 16. In exercises 15 through 28, identify the variable part and the numerical coefficient. And so I have a negative p squared. So the variable part for this particular term is p squared, and the coefficient is a negative 1. Again, because negative p squared can be thought of as negative 1 times p squared. Let me do problem number 26. 12. And so in this case, the variable part is 1 and the coefficient is 12. That's a 26. Let me do problem number 32. 12q and 2r. In exercises 29 through 40, determine if the pair of terms are like terms. So two terms, well, terms will be considered as like terms if the variable parts are identical. So in this case, well, the variable parts are q and r, and so no, these are not like terms. Problem number 36. Negative x, y, z and x, y, z. In this case, the variable parts are the same. They're both x, y, and z. Therefore, these are like terms. Problem number 40. 10 x squared y and negative 10x y squared. Well, in this particular case, the variable parts are x, y squared and x squared y. These are not identical. Therefore, since the variable parts are not identical, these are not like terms. Okay. Let me do problem number 42. 20x minus 7x. In exercises 41 through 72, simplify each expression by combining like terms. Well, since I have like terms of 20x and 7x, well, 20 apples minus 7 apples is 13 apples. And so 20x minus 7x is 13x. Let me do problem number 51. 3y minus 2x plus 2y minus 6x. And so this is the same as 3y, distributing the negative sign inside the parentheses, minus 2x minus 2y minus 6x. 3y minus 2y is 1y, minus 2x minus 6x is a negative 8x. let me do problem 63. Negative 6x minus 3, 2x minus 5x plus 8 minus 6. Let me multiply the negative 5 inside the parentheses, simplifying the innermost parentheses first. So negative 6x minus 3 times the quantity 2x minus 5x minus 40 minus 6. Combine like terms inside the parentheses. And so 2x minus 5x is a negative 3x minus 40 minus 6. Let me multiply the negative 3 inside the parentheses. So by this derivative property, I have negative 6x minus 3 times minus 3x is a positive 9x. Negative 3 times negative 40 is a positive 120 minus 6. Nine x minus 6x. These are like terms, so I can combine like terms. 9x minus 6x is 3x. Similarly, 120 and 6 are like terms. 120 minus 6, 114. Let me do problem number 70. Negative 3/8 question. Oh, question. Yes. Are we in session yet? Yes, we are in session. Yes. Okay. That was the only question. Okay. Yes, we are. Problem number 70. Again, if you have any questions, you can always type them into the text box and I will, answer those questions. Negative 3/8 times 24a squared minus 1/4 times negative 16a squared plus 3/5 times negative 5a squared. Okay, well, let's simplify this. Negative times positive is negative. 24 divided by 8 is 3, times 3 is 9, a squared. I don't see no. Oh, you hear me, but you don't see what I'm typing? Oh no. Okay, so let's just see. Does anyone else see the background here? You can't. Okay. Oh no. Oh no. I thought it was just me. Oh no. Okay. 1 second. Okay. Can you see it now? Okay. Thank you. So sorry. Okay, okay, good. Um, Actually, amazingly enough, what I've been doing so far is what we did in class on Thursday. So the last thing we did on Thursday was problem, I think 63. So I'm not actually. I can start this problem over again. So everything that was seen before or wasn't seen before was seen in class. Okay. So let's multiply -3/8 times 24a squared. I'll just write this as over 1. 24 divided by 8 is 3. -3 times 3a squared is a -9a squared. -1/4 times -16a squared. Again, let's write that over 1. Negative times negative is positive. 16 divided by 4 is 4. And so this is equal to a positive 4a squared. And lastly, 3/5 times -5a squared. Again, let's write that over 1. Positive times negative will be negative. The 5's cancel, and so you get 3 times -a squared is a -3a squared. Okay. And so now, notice that the -9a squared, the positive 4a squared, and the -3a squared, they're all like terms. They're all terms with a variable part of a squared. And so let's combine. And so 4a squared minus 3a squared is 1a squared, minus 9a squared is a -8a squared. Any questions about that? Okay, so let me do problem number 74. -6 minus 2x plus 9. In exercises 73 through 102, simplify the expression. And so let's combine like terms. Well, -2x, there's no other like terms with that, so just -2x. I have a 9 and a -6. Those are like terms. 9 minus 6 is +3. The -2x and the 3 are not like terms, therefore we can't combine them, and so we've simplified this as much as possible. Let me do problem number 80. -6x plus 15 minus 20 plus 12x. So let's combine like terms. Well, 12x and -6x, these are like terms. 12x minus 6x is 6x. 15 minus 20, well, these are like terms, so I could combine them. -5. The 6x and the -5 are not like terms. Therefore, we've simplified this as much as possible. Let me do problem number, question. No, remember, never solve for anything if it's an expression. These are expressions. And so if you looked in the book, you would notice that these were written without any equal signs. They were just this first line here. And so these are expressions. You never solve expressions. You simplify expressions. You solve equations, not expressions. as a matter of fact, we have yet to determine how to solve anything. Um, we've only shown that something can be a solution, but we have no techniques yet to solve equations. Let me do problem number 98. 2/5 x minus 5 minus 1/5 x plus 20. Okay, so let's multiply the 2/5 inside the parentheses, the negative 1/5 inside the parentheses. So in this case, since it's an expression, the only thing you can do is simplify it. And so I can use the distributive property to simplify it, and that's it, really. And so 2/5 times x is 2/5 x. Positive times negative is negative. 2/5 times 5, well, the 5's cancel, so you get negative 2. Negative 1/5 times positive x. Negative times positive is negative. 1/5 times x is 1/5 x. Negative 1/5 times positive 20. Negative times positive is negative. 20 divided by 5 is 4. And so 1/5 times 20 is 4. Now let's combine like terms. I have 2/5 x minus 1/5 x. Luckily, 2/5 and 1/5 are have the same common denominator, so I don't have to worry about finding a common denominator. We already have one. And so 2/5 x minus 1/5 x is just 1/5 x. Negative 2 minus 4, these are like terms. I can combine them. Negative 2 minus 4 is a negative 6. The 1/5 x and the 6 are not like terms, and so we do not combine them. And therefore, I've simplified this as much as possible. 1/5 x minus 6. Let me do problem 104. In exercises 103 through 116, convert the word phrase into a mathematical expression, use x as the variable, and simplify the resulting expression. So we're going to, again, have an expression, and we will want to simplify this expression. And so this is going to be the sum of two consecutive integers. Okay, and so, well, let's consider if I had a integer 8, then the next consecutive integer would be 9. If I had a integer 14, then the next consecutive integer would be 15. If I had an integer x, then the next consecutive integer would be x plus 1. Because notice that these are always one more than the previous guy. And so let x be your variable, the smaller integer. Okay. Then x plus 1 is the next consecutive integer. I don't know. And so x plus 1 is the next consecutive integer. Therefore, the sum of the two consecutive integers are, well, here's the first integer, and here's the next consecutive integer. And so this is just going to be, well, I can get rid of the parentheses. 1x plus 1x is 2x. And that is your answer. Yes, sure. So suppose we had, you know, 43. What's the next consecutive integer? Well, what's the next guy in this list? Well, 44. 2. What's the next consecutive integer? 3. And so, 18. What's the next consecutive integer? Well, it's going to be, it's going to be one larger, 19. And so, if I give you some number, what's the next consecutive integer? Well, that number plus 1. And so, if I gave you an x, then the next consecutive integer would be x plus 1. Okay? It's always one larger. Okay, good. And so in general, students do have a hard time with this concept. Um, Usually what happens is they'll just sort of they'll just write x plus 1. They'll say, oh, that's a sum there or something, but that's just indicating the next consecutive integer. And so you have to add it to the first integer. Okay, let's do problem 106. The product of two consecutive even integers. Okay, so now, well, suppose I had the integer 8. What's the next consecutive even integer? Well, the next even integer would be 10. If I gave you 2, the next consecutive even integer is 4. 84. The next consecutive even integer is 86. And so if I give you x, then the next consecutive even integer is x plus 2. And so let x be the smaller integer. Then x plus 2 is the next consecutive even integer. Okay? And so now we want the product. And so the product is going to be, well, x times x plus 2. So this is the product of the first even integer times the next consecutive even integer. So now let's use the distributive property to multiply the x inside the parentheses. So again, multiplication distributes over addition. X times x is x squared. X times 2 is 2x. And that is your answer after I've simplified it. So after I've simplified the expression, that's what it's equal to. Let's do problem 116. 5 times a number added to twice the number and decreased by the difference of the number and 8. Okay, so let's do this. And so I have 5 times a number added to so 5 times a number added to twice the number. So that means 2 times the number. And then decreased by, that's a minus, the difference of what? The number and 8. So I'm going to have to decrease it by the difference of the number and 8. Oh, in this case, it doesn't make any difference. You can write this is 5x plus 2x or 2x plus 5x. But since it says it's added to, the 2 here means that you already had something. And so the 5x was added to this previous quantity of 2x. And so it sort of, it reverses the, it, it reverses the order in which you wrote the addition. But the addition is commutative, so it really doesn't make any difference. So a lot of times we just, yeah, because it says it. Oh, no, because it says two, the word two. Here, let me, T-O. Like, this is not dropping. Okay, so because of it's added to. And so because it's added to the number, then it's the 5x was added to this previous quantity of 2x. So there was this 2x here, and we added to it the 5x. But again, it really doesn't make any difference. If you wrote 5x plus 2x, I'm not going to take any points off. Okay, so now let's combine like terms. 2x plus 5x is 7x. I have a negative outside of parentheses, so by the distributive property, let me multiply the negative inside the parentheses. Negative 1 times x is a negative x. Negative times negative 8 is a positive 8. Combine like terms. 7x minus x is 6x plus 8. Any questions about that? Okay. Good. So that really finishes off